In this second video on solving simultaneous equations using the method of elimination, or elimination method, I'm going to solve the second example that we see here. And for that, we'll use the same three-step method that I showed you in the first video, but this time, to save a bit of time, I won't write it all out. I'll just write step 1, step 2, step 3. So let's go ahead. When solving a pair of simultaneous equations like this one, before starting, we should always label or name the two equations we have. Nothing fancy, I'll call this first equation E1, and I'll call this second equation E2, as in equation 1 and equation 2. Alright, now just as I did in the previous video, what I'll do here is solve this pair of simultaneous equations twice. The first time I'll solve it by eliminating the y from these equations, and the second time I'll eliminate the x's. And in fact, I'll go ahead and write that here. I'm going to eliminate y. Okay, so to do that, there are 3 steps. Step 1, we need to make sure that there are as many y's in both of these equations. And looking at equation 1, we can see that it has 3 y's, and equation 2, on the other hand, well, it has 4 y's. And so to make sure that they both have as many y's, we could look for the least common multiple of 3 and 4. And if it helps, you could do that on a piece of scrap paper, and I'll just write that in light gray here. The multiples of 3 are 3, 6, 9, 12, 15, and so on and so forth. And the multiples of 4, well, those are 4, 8, 12, 16, 20, and so on and so forth. And it doesn't take us long to see that the least common multiple of 3 and 4 is 12. And 12 is the fourth multiple of 3. Indeed, we have 1, 2, 3, 4. And 12 is the third multiple of 4. So I'll go ahead and make sure that we have 12 y's in both of these equations. And for that, I'll multiply the entire first equation by 4, and I'll multiply the entire second equation by 3. So let's go ahead, and I write what I do. So I said I'll multiply the first equation by 4, and I'll multiply the second equation by 3. So that's 4 times E1 and 3 times E2. Okay, multiplying the left-hand side of the first equation by 4, we'll have 4 times 2x, which is 8x, minus 4 times 3y. So that's minus 12y. And I'll go ahead and write that. That's 8x minus 12y. And that will equal to 4 times the right-hand side. So that's 4 times 1, which is 4. There we go. That's our new equation 1. I now multiply the second equation by 3. And so taking care of its left-hand side, we'll have 3 times 3x, which is 9x, plus 3 times 4y, which is 12y. So that's 9x plus 12y. And that will equal to 3 times the right-hand side, so that's 3 times 10, which is 30. There we go. That's our new equation 2. And now that we have the same number of y's in both of these equations, that's our first step done. And so we move on to step 2. And in step 2, we're going to combine the two equations we now have, which we do by either adding them together or by subtracting one from the other, in such a way that the y's, since we decided to eliminate y, disappear. Now, to make sure that the y's disappear in this case, since there's an opposite sign in front of the y terms in each of these two equations, we're going to add them together. Indeed, by adding these two equations together, we'll have negative 12y plus 12y, which is 0. And so we'll eliminate the y's that way. So let's go ahead. I'll write E1 plus E2. We're adding those two equations. Adding the left-hand sides together, we'll have 8x plus 9x, which is 17x, and we'll have negative 12y plus 12y, which is 0y, and that's just 0, so we don't bother writing that. And that will equal to the right-hand side of E1 plus the right-hand side of E2, so that's 4 plus 30, which is 34. Notice here that by combining these two equations this way, we went from 2 equations with 2 unknowns to 1 single equation with 1 unknown. So we can solve this. Indeed, on the left-hand side here, x is being multiplied by 17, and so to get rid of that 17, we'll divide both sides by 17. And that leads to x on the left-hand side equals to 34 divided by 17, which is 2. And we've now found the unknown x. And as such, that's step 2 done. So we move on to the third and final step, step 3, in which we use the result we just found as well as either one of the two equations we started off with, to find the other unknown, in this case, y. Okay, well I could use either one of these two equations, it doesn't matter, but to avoid working with anything negative, I'll go ahead and take this second equation, e2. And so I'll go ahead and write that I'll use e2 with the result we just found, so with x equals to 2. So copying this second equation, but replacing the x that we see here by the value we just found, it turns into 3 times 2 plus 4y equals to 10. Now 3 times 2 is 6, so that's 6 plus 4y equals to 10. And solving this equation for y, I start by subtracting 6 from both sides. And in fact, I'll write that. I'll subtract 6 here and I'll subtract 6 here, which leads to 4y equals to 10 minus 6, which is 4. And finally, since y is being multiplied by 4, I divide both sides of this equation by 4, which leads to y equals to 4 divided by 4, which is 1. And we're done. We've now found the second unknown y. X equals to 2 and y equals to 1 are the solutions to this pair of simultaneous equations. And in fact, we could check. Replacing the x's and the y's in both of these equations by 2 and 1, we'll find that the left-hand side of this first equation equals to 1, and that the left-hand side of the second equation equals to 10. Indeed, replacing x by 2 and y by 1 in this first equation, we'll have 2 times 2, which is 4, minus 3 times 1, which is 3, so that's 4 minus 3, which is 1. And in the second equation, replacing x by 2 and y by 1, we'll have 3 times 2, which is 6, plus 4 times 1, which is 4, so that's 6 plus 4, which is indeed equal to 10. So these solutions are definitely correct. And as such, we're done. We've just solved this pair of simultaneous equations using the method of elimination. And in the working we see here, we did so by eliminating the unknown y. But as I said at the beginning of this video, we could have also solved this by eliminating x. And so in fact, I'll use the second portion of the screen here on the right-hand side to solve this pair of simultaneous equations again, but this time I'll eliminate x. And so I'll write that at the top here, I'll eliminate x. So let's go. I'll start by copying the equations we had. We had 2x minus 3y equals to 1. That was equation 1. And we had 3x plus 4y equals to 10. That was equation 2. So we go back to our three-step method, and step 1, remember, since we're eliminating x this time, we need to make sure that we have the same number of x's in both of these equations. Well, looking at the first equation, it has 2 x's, and the second equation here has 3 x's. And to find out how many x's we want in both of these equations, we can look for the least common multiple of 2 and 3. And I have no doubt that you can find that without using pen and paper. But just in case, let's go ahead and write the multiples of 2. Those would be 2, 4, 6, 8, 10, and so on. And the first few multiples of 3, well, those would be 3, 6, 9, 12, 15, and so on. Looking at these two lists of multiples, we quickly see that the least common multiple is 6. Indeed, 6 is the third multiple of 2 and the second multiple of 3. And so I'll go ahead and make sure that we have 6 x's in both of these equations. And to do that, we'll multiply this 2 here by 3. And so we'll multiply this entire first equation by 3. And we'll multiply the 3x we have here by 2. So we'll multiply the entire second equation by 2. And we make sure to write that. So we say 3 times e1 and 2 times e2. There we go. Okay, well, multiplying the entire left-hand side of equation 1 by 3, we'll have 3 times 2x, which is 6x, minus 3 times 3y, so that's minus 9y. I'll quickly write that. That's 6x minus 9y, and that will equal to 3 times the right-hand side. So that's 3 times 1, which is 3. That's our new equation 1. Next, I take care of equation 2, which remember we said we'd multiply by 2. And so the left-hand side will become 2 times 3x, which is 6x, plus 2 times 4y, which is 8y. So I'll quickly write that. That's 6x plus 8y, and that will equal to 2 times the right-hand side, so 2 times 10, which is 20. There we go. And that's our new equation 2. Now that we have as many x's in both of these equations, our step 1 is done, and we move on to step 2. And in step 2, remember, we combine the two equations we have, either by adding them together or by subtracting one from the other, in such a way that the x's disappear, or rather in such a way that we eliminate the x's. Now looking at both of these, we can see that we have a positive 6x in both of these equations, so adding them together won't do. Indeed, to eliminate the x's here, we need to subtract one equation from the other. And it doesn't matter whether we subtract e1 from e2 or e2 from e1, but I'll go ahead and subtract e1 from e2. And so I'll go ahead and write that now we combine them as e2 minus e1. There we go. Okay, on the left-hand side we'll have 6x minus 6x, which is 0x, in other words 0, so we don't bother writing anything there. And we'll have 8y minus negative 9y. And in fact, I'll write that out to not make a sign error. That's 8y minus negative 9y. And that will equal to the right-hand side of e2 minus the right-hand side of e1. So that's 20 minus 3, which is 17. Notice that we've gone from two equations with two unknowns to one single equation with one unknown. So we can solve this. Now, 8y minus negative 9y turns into 8y plus 9y, and that's still equal to 17. And 8y plus 9y, well, that's 17y. So we have 17y equals to 17. And now since y is being multiplied by 17, we divide both sides by 17 to state that y is equal to 17 divided by 17, which is 1. And we now have the unknown y. Notice that it's the same result as we had found previously, as it should be. And now that we have y, we move on to the third and final step, step 3, in which we use the result we just found, y equals to 1, along with either one of the two equations we started off with, to find the other unknown, in this case x. Well, let's see, I think I'll choose the first equation, e1, but let me insist, it doesn't matter which of the two equations you choose. But here I'm using equation 1 with the result we just found, so with y equals to 1. Okay, so copying this equation, but replacing the y we see here by 1, it becomes 2x minus 3 times 1 equals to 1. That's 2x minus 3 equals to 1. And carrying on with my working over here, and in fact I'll copy that last result, 2x minus 3 equals to 1, I now solve this equation for x. For that, I'll start by getting rid of this 3 that's being subtracted from the left-hand side, and I do so by adding 3 to both sides. So it becomes 2x equals to 1 plus 3, which is 4. And I now get rid of this 2 that's multiplying the x, which I do by dividing both sides of this equation by 2. Finally, we can state that x is equal to 4 divided by 2, which is 2. And we're done. We now have the second unknown x. And notice again that the value that we're finding for x here is the same as the value we had found when we eliminated y. And that's just as it should be. And there we have it. Those are the 3 steps we can use for solving simultaneous equations with the elimination method. And that's it for this tutorial.